So, hi. In this question, we are asked to find out the total time taken to transmit a data packet of length 1000 bits from a particular station to another particular station. Okay, so here we have a station A and here we have a station B. Now, both the stations are connected via an Ethernet line, which is actually a CSMA by CD network. And because Ethernet is by default CSMA by CD, so both of these have to transmit the data. And let's see how we have to do this type of particular sums. So, because all of these sums have this type of particular template and will slightly differ in all those cases. So I am explaining the most common two templates of this type of sum. So let us consider that both of these will start their transmission at time t equal to 0. Okay, so at time t equal to 0, A will transmit the data and B will also transmit the data, and it will take this and it will take this, and they will collide somewhere in the middle here, and it will take exactly how much time? It will take exactly the half of the propagation delay to reach here. What is half of the propagation delay? It is actually 5 microseconds, and here also it is actually 5 microseconds. Okay, now at time t equal to 0, here A and B start transmission. Okay, A and B are starting their transmissions. Okay, here A and B are not detecting collision, but collision occurs in this case at time t equal to 5. Collision occurs. We are not detecting it. We are just saying that collision has occurred. Now, as we know that in case of a CSMA CD, collision signal will again go back to the respective channel, because the respective channel has the duty to inform all the other stations in the channel that, you see, there is a collision. Please don't send your data now. Okay. Now it will again flow back. This will also flow back. Now, what is the time taken to flow back these signals? It is again the same time, which is actually 5 microseconds, and this is also again 5 microseconds. So we need to say that t equal to 10. This is again, now at this point, after this at t equal to 10, after this point at t equal to 10, the collision has been detected by both these stations A and B. Collision detected by A and B. Both A and B, the collision will have to be detected at this point. Okay, now there is a catch in the question, that it has written that jam signals are ignored. Okay, jam signals are ignored. Now, what is this jam signal? Jam signal is actually a 48-bit signal which is sent by the collided station. Okay, the station which has faced the collision, it will send this signal in order to inform the other stations that please don't send your data now, because if you send the data, there is already a collision in the channel, and there is high probability that the channel is still not empty and you may again collide. Okay, so this is the role of this jam signal, and we have to ignore this jam signal as written in this question. So many times in some other templates of this question, they also mention a jam signal, and that is nothing. They will mention the amount of the bits required for the jam signal, and you have to calculate the transmission time divided by the total transmission time. You have to calculate the total transmission time, means the length of the jam signal divided by the bandwidth that has been provided in the question. So that is the only thing you have to extra add in that part. Okay, so here we totally ignoring the jam signal. And now there is one more thing that is very important, because you can consider that the channel is now totally empty and we can safely transmit the data, but it is not actually the case, because let us consider that this is our channel. Okay, and you have sent a data bit here, and this bit has to be fall of this channel. Similarly, this bit which has been transmitted, this has to be fall of this channel until we transmit a until we start a new transmission. Okay, this is the reason for this is that if this packet goes here, so let us consider that this bit goes here at the end of the total propagation delay, and you are transmitting the data here, and because of the too much pipelining of the data, it has came here, and suddenly this data also came there and this data also came there, and last bit may get ignored, or it may face again collision, and sometimes error will occur. Okay, not everywhere error will occur, because it can be fall off the data will fall off the channel earlier also, or but it cannot fall off more than the propagation delay, because obviously that is the maximum time that it will take for a particular data bit to travel this channel. So we have to wait another 10 microseconds so that the last bit from each channel, from each station of the channel, will fall off the respective channel. Okay, from each station will fall off the respective channels. Respective channels, here we cannot say respective channel, here we have only one channel, means for a particular station, if what is the last bit will have to fall off that channel. Okay, you can consider this as an example. If you think this is tough, we can consider this as a very simple example is there. Like let's consider that this is a road, and in this road the cars are traveling from here to here, which is from, let us may mark this as A and C. The cars are traveling from here to here, means the signal is green in this case. Okay, signal is green, and some cars are standing here, some cars are standing here, and this is B and D. Now cars are standing there. Now this is green. Now suddenly the signal turns green to red, and a car is here, which is exactly at the middle of the 4 roads. Okay, now what will this do? Now these cars have to wait until this car goes away, otherwise it will again collide with that car. But this is not always the case. Now this will always happen. There is no probability that this will always happen. Similarly, here it is also the case. There is no guarantee that it will always happen, but there is a case it will happen. So we have to consider the worst case possibility in this case. Therefore, these cars have to wait until this goes off. Hence, here also we have to wait until the last bit from each respective station falls off their common channel. Okay, the common channel falls off their common channel. Now, what is the waiting time? What is the waiting time? Waiting time is actually again the propagation delay, which is actually 10 microseconds. So the total time here we have waited till 10 t equal to 10, then again t equal to, again 10 microseconds we have to wait. It will go until t equal to 20 microseconds, and now you can safely start your transmission. Now what is the transmission time? Now transmission time is equal to how much? It is actually 1000 by 10, which is actually 0.1 millisecond. 0.1 millisecond, which is actually 100 microseconds. Okay, 100 microseconds, and again it will take its respective propagation delay. This is because we are transmitting, because there is k equal to 0 for the station A or station B, I guess mentioned in the question, that which station will have the least number will get the chance to transmit the data. Okay, and for TP it will again take the same time, that is 10 microseconds. Okay, now you can add these 3, that is the total propagation delay will now become 130 microseconds. I guess it's clear now.